All right, so let's talk through the lab really quickly. So hopefully you got the mass recorded appropriately, the total pressure that was up on the board in inches of mercury, and the temperature in degrees Celsius, and your volume that you got at the end. The first thing is you're going to calculate the air pressure in millimeters of mercury. Hopefully many of you did this while you were doing the lab, but whatever it was I gave you in inches of mercury, you're going to then convert it. We're going to put inches of mercury on bottom, millimeters of mercury up top. Now, I gave you the conversion in class. If you weren't here, you missed it somehow. The conversion is 25.4 millimeters equals 1 inch. All right, from that, then you can cancel out your inches of mercury and leave you with millimeters of mercury. So that's A. B, converting the temperature into Kelvin. I'm hoping you're feeling strong on that now. Let's see, the C, using the mass. So you got a mass of magnesium. What you're going to do is you're going to take whatever your mass of magnesium was, whatever grams of magnesium, and you're going to use this conversion I gave you. I know we haven't gone over mole to gram conversion, so that's why I'm just giving it to you. All right, that'll cancel out grams. And then I said that whatever you get is your moles of magnesium, which is the same as the moles of H2, which is what you'll need for this set of calculations that follow. So hopefully you're able to do that with whatever your number you got for your grams was. D, you're determining the partial pressure of H2 because that's what we're interested in. So we're trying to find H2. The P total, that's going to be from A. The pH2O, the partial pressure of water vapor, this is what you're going to find on the table. So if, we know what temperature, we know that we did the lab, it was 21 degrees Celsius. So I gave you the table down here at the bottom. So all you need to do is look for 21 degrees Celsius. You get 18.6 millimeters of mercury. Or if you were doing it based off of the video, you would use whichever one corresponds to the temperature that they had there. I don't remember what it was off the top of my head. All right, so you're going to take the temperature, you find your partial pressure of water there, and then you should be able to solve for your partial pressure of H2. Then you're going to find R. Now, we all know that PV equals nRT. And I know many of you are like, wait, Dr. Ricker, R is a known. Why are we trying to find R? Well, we're experimentally finding this constant and seeing how closely we can get to finding this constant. Okay, so if we were to rearrange this, we divide by NT. So now we have this equation, R equals PV over NT. Now this would be if I had like total pressure and total volume. Well, we do have a total pressure, or not total volume, total moles. We do have a total pressure, but we don't know the total number of moles because we don't know how many of those water molecules went into the vapor phase. But we do have a partial pressure. So, and we just found that, and a volume, and we know the number of moles of the H2. Alrighty, so this partial pressure, let's see, that came from part D. This is from your data. This is from part, let's see, we converted it to Kelvin in part B. Sorry to keep going back and forth. I just don't remember where we did each of these. And then we have the moles of the H2. Sorry to go up again. In part C. All right, so you have all the numbers there. Make sure that you're calculating this with correct sig figs and accounting for all your units. You need to be putting units into your calculations. Once you have an R value, that's our experimental value. Okay, so we're going to calculate the percent error. So how closely we got to the accepted value of R. So percent error is the experimental value minus the accepted value over the accepted value. All right, the accepted value of R, well, we want to use the R that is in the same units as ours. We did all of our calculations doing millimeters of mercury, so just use the ones that's millimeters of mercury. So if you look on your equation sheet, you'll see 62.4 liters, millimeters of mercury per mole Kelvin. That will be your accepted value. Your experimental value is going to be equal to your number that you got in part E. Okay, you should be able to get a percent error. So this equation here, this equals our percent error. Remember, I don't use absolute values around that because it just gives you a little bit more information. As in, if you have a negative percent error, that means that you're below the that you're below the accepted value. If you have a positive percent error, that means you're above. It just gives me a little bit more information that you can share by just sharing one number. So don't stress if you end up with a negative. It just means that your R value was below that of the accepted. All right, in the conclusion, you're just going to do one sentence summary of what you did in the lab. Okay, like we found the ideal gas constant experimentally by reacting magnesium and hydrochloric acid and using partial pressures or something along those lines. From our data, we determined that the ideal gas constant is, so you will put in what you got from part E with a percent error of, and this is what you'll put in from part F. Make sure that they actually match. And then reflections, I want you to talk about error. In general, I want you to talk about 3 different sources of error that might have occurred during the collection of your data. Do I want you talking about calculations error? No, I want you talking about what happened while you were doing the lab, all right? So things that you could fix in the future. I don't remember no human error and no calculation errors. Those are not acceptable. Okay, you can say things that you did that were an error, but do not use that phrase, human error. So you can list things like, hey, there were bubbles on the walls of the eudiometer that were not read in our final volume reading. You could do things like our magnesium didn't fully react. Or when we put the whole thing together, we had some air bubbles before we even started seeing a reaction occur that would have changed our volume. Or maybe when you're carrying it up to the front to equalize the pressures in that front giant graduated cylinder, you might have accidentally let some liquid out and an air bubble came in, further changing your volume, right? We've got a lot of options that you can pick from. So think of the 3 that make the most sense for your lab and your experience. All right, once you've done all that, make sure that you correctly submit it within Schoology so that way I can grade it. Excellent job.